Hello everyone, welcome to topic 7.5, magnitude of the equilibrium constant. By the end of this, you should be able to explain the relationship between very large or very small values of K and the relative concentrations of chemical species at equilibrium. So the goal at the end of this is based off of a large or a small K value, be able to predict, are you going to have lots of products or lots of reactants? In the previous lesson, you learned how to perform calculations both to find the value of the equilibrium constant and to find concentrations or partial pressures when you have the equilibrium constant. However, the meaning of the value of the equilibrium constant hasn't been covered. Reactions with equilibrium constants that are greater than 1 are said to favor products, while those that are less than 1 favor the reactants. If the order of magnitude is very big, like 1,000 or bigger, we say that it goes to completion. If it is very, very small, less than 0.001, we say that the reaction barely proceeds at all, or if it's super, super small, like even smaller than that, sometimes we can say that there is no reaction. But usually we will still perform the math to show that almost nothing is made, just to prove a point and that we know what we're doing with really silly numbers. So let's look at this. Given the following reaction, what could be said about the relative amounts of the reactants and products when you reach equilibrium? Explain. So we look at the order of magnitude. This is 10 to the 7th, which is much bigger than 10 to the 3rd, which is our guideline for going to completion. So there are only, because grammar, might be a good thing. So there are only nope, not reactants. Wow. Products. Because K is very large, so the reaction goes to completion. Okay. Now let's try the we do. Given the reaction below, here, and the K value, if 1 mole of A and 1 mole of B were placed into a 1-liter container and allowed to reach equilibrium, what would be true of the partial pressures of the gases at equilibrium? Explain. Okay, so you want to pay attention. I'm going to have you guys do this. You're going to pay attention to the stoichiometry, the -4 exponent, and select your answer. So please pause the video and complete the we do on your own, then resume the video after you've tried. So for this one, because of the order of magnitude, you should notice that A and B should be much larger than C, because it's not going to favor the products. It favors the reactants due to the nature. So much more A and B will be present at equilibrium than C. Now looking at the ratio of A to B, 2A reacts with every 1B. So A is used twice as fast, so the amount of B will be much greater than the amount of A. So that tells us it must be C, where A is less than B, but B and A are much bigger than C. So this completes this set of notes. Complete the you do, check your work, and thank you for tuning in.